Hey everyone, and how goes it? Welcome back to Computer Science 552 Game Development. I'm your instructor, Dr. JJ Shepard, and today we're going to continue discussing game design and game development. In the past lectures, we've focused on the concepts and roles related to game production and discussed the concepts related to game design. Today, we look at some of the last parts of game design so we can use this concept in order to develop a game. Still within our pre-production process, we once more turn our attention to the programmer creating the technical design document. We've explored the game loop pattern along with the game object and component structural pattern to create game code. Now, we put those plans in place by creating a programming task list. The programming task list is a detailed list of necessary programming assignments needed to create the game. If we put sufficient time in designing the game software, then creating a task list is simple. This list easily is derived from our list of game objects and their associated components. We then prioritize programming tasks based on the game's necessary features and their dependencies. We've already taken the necessary features provided by the game design document and modeled them as game objects and components structurally in our technical design document. We have also modeled the dependencies between the various game objects and components by using the game object and component structural diagrams in the technical design document. When one game object or component is associated with another, we use the arrows to demonstrate the relationships as a graph. In reference to establishing dependencies, I suggest asking, where does the arrow point? Once we follow the arrows, we can start seeing what depends on what and start creating a plan and a sequence for all the tasks to be completed. However, we should keep in mind that the task list is not exactly the same as a schedule. A production schedule we will discuss a little bit later, but the task list is only the sequence of programming tasks, but is not directly when they need to be done. These details are provided in the schedule later. Now we turn our attention away from the programmer for a moment, but still within our pre-production process. We turn our attention to the role of the artist. We look briefly into how to create the art list. As mentioned in a previous lecture, the art list is a comprehensive list of all the game assets required. This contains a list of the visual assets like sprites, 3D meshes, textures, animations, and also audio assets like sound effects, music, recorded dialogue, etc. It also contains story assets like context, story documents, screenplay, plot synopsis, dialogue scripts, character lists, etc. This all assists in creating a development schedule. No matter the type, we must keep track of the asset information in this list. Some of the most necessary elements are the descriptive name and a brief description. The file name is important to reference and also the file type, format, and specific details. These change depending on the type of asset. It's also important to keep track of which associated component, game object, or scene that the asset is associated with. A good way to write this is using a spreadsheet as the art list inside the game design document. As simple as it may sound, having naming conventions for your asset files make a world of difference. This helps bridge the gap that can exist between the artists creating the assets from the art list and the programmers who need the assets in their code. There is not a single way to do this, but having information like the type of asset, related scene, game object, or component, and a reference number in a specific format can be important. For the types of assets, we can consider to use TEXR to stand for texture or for a 2D visual asset, SFX as standing for sound effects, MESH for a 3D model, ANIM for an animation, etc. For related scene, game objects, or components, we can use SC, GO, and CO for each one. The specific format would order each one of these parts and provide a means to separate it, such as an underscore. We can see in this example how the type, related name, and number are separated using an underscore. Putting this together, for example, we can consider the name texr_go_stone_001.png to be a reference to a texture for a game object called stone number 3. When developing the art list, each artist should look for the nouns in the game design document and the geos in the technical design document. For visual artists, they should especially look for characters, settings, and objects of interest, objects of decoration, interfaces, and menus. For characters, make sure to note each one and also include their actions and verbs, as these will be associated with a component and will be associated with an animation. The adjectives will provide guidance for the character's design. Settings is also important to look for. Natural, urban, fantasy, futuristic are all associated adjectives that help us develop a setting. However, setting can feel empty if we don't decorate it properly. This is where objects of decoration come into play. Depending on the setting, we may need to note if we need to create buildings, trees and plants, or other clutter like books or containers to help create a believable setting and add some attention to detail. Besides setting the scene, we also need to consider other objects of interest. More often, these are interactable objects that play a significant role in the game. We can consider health containers, keys for doors, tools, and other types of pickups are objects of interest to look for. These may also have associated animations as well. Visual artists must also consider the different menus and interfaces in the game. Both of these deal with the graphical user interfaces or GUIs. Some common menus would include the main menu, settings, and pause. Common interfaces such as a heads-up display or a HUD, health bar, and inventory systems. With all of these, we need to consider creating backgrounds, buttons, sprites, and even fonts in order to create these. The game design document should contain some rough sketches of all of these different interfaces. Now that we've established what we need for the look of the game, we now turn our attention to sound. A good rule to remember is every action makes a sound. This means in a similar way, we need to look for the nouns and the verbs in the game design document. Also in a similar way, audio artists look for character settings, objects of interest, objects of decoration, interfaces, and menus. For instance, characters and objects of interest, a sound designer will look for the verbs that correspond to the components. Every action makes a sound, and we should have associated sound effects with each one of these actions. Running and jumping would obviously have different sound effects, but also running and walking would have different sound effects as well. We can consider other actions like collecting an item to have a sound effects to provide a meaningful feedback to the player. For settings and by extension, objects of decoration within those settings also make sounds. Ambient sounds from the environment and objects help to create an engaging atmosphere for the game. We may also further augment the experience by using music. Interfaces and menus are also considered as every button click makes a sound, and many times different sounds depending on the different menus and interfaces. There are also other interface sounds to consider as well, like selecting and even background music for ambience. It can be easy to overlook the importance of sound, but when it is not done correctly, the player will always notice. This attention to detail can make or break the entire experience. We also have a section of the art list for assets related to story. However, some of these details are not exclusively found in the art list. Story assets are directly related to the dramatic elements of the game. This means the game designer, who we consider to be the artist in their own right, defines the characters, the premise, and the story within the game design document, and this is not part of the art list. The art list would contain detailed story components in the form of screenplay, dialogue scripts, and other story documents. In relation to all of this, scripted cutscenes may require story, audio, and visual artists all working together. It's at this point we need to critically discuss the details of the art assets. We know that there are visual, audio, and story involved, but these do not exist alone in space. They must be utilized by the programmer in order to create the game itself. With this in mind, we must know that it is important for the artist to consult with the programmers about the asset details. A major detail with all of the assets are the file types and their formats. Understanding the different common file types and formats for visual and audio assets comes with knowing about specific underlying details. We must know what file types that are supported by a game engine and its importers. We will learn that game engines have importers to process the art assets so they are usable by the game engine. These only recognize certain file types. The programmer must know these details and provide them to the artists. In addition, both the programmer and the artist must be aware of the advantages and disadvantages of different file types and formats, which allows them to understand the trade-offs. For example, a visual asset, we may need to know whether or not we're using a PNG versus a JPG. We will learn that a PNG file provides an alpha channel for transparencies, while a JPEG does not provide this, but it may be smaller in size. Another question related to audio assets would be whether or not we're going to use a WAV file format or an MP3. As we will learn, a WAV file for music would be a lossless format, but the file size would be huge, while an MP3 would be much smaller, but it provides lossy data. The artist must know the type and the file details required by the programmer. The artist must know the software that is to be used to create these file types. Software used to create the art assets only can export a certain number of file types, and it's good to be aware to know which software supports which types. Now we have the art list in place, along with the technical design document. We can now move to the next part of pre-production, scheduling. The producer plans for everything, and the more details the better. The producer creates the schedule based on milestones. These mark a significant point in the development process. This allows the project to be broken into smaller parts. Each milestone results in deliverables, which are completed game features. To avoid conflict, milestones and their resulting deliverables need to be specific. Exact times, exact formats, exact modes of delivery. Some of the common milestones to consider are the programming milestones. These will be related to the features being developed and based on the technical design document and would be written in the task list. Visual and audio assets being delivered is another set of milestones. It is good to have approval schedules for each asset in the art list. From here, having a playable demo is created as an important proof of concept. This is also where the marketing materials are considered, and we need to pass these along to the publishers to help sell the game. Having the approval from the licensors and the platform holders, along with the game being greenlit in various meetings, are critical to the schedule as well. Close to the end of production, we look at getting an ESRB rating and need to have a nearly complete game by this point. It is also worth considering vacations and holidays, as these will factor into an overall schedule. The parts listed are mostly in order, but there isn't an exact formula. Many of these milestones have smaller milestones, especially programming ones, that should be mapped out in detail. Whenever you're developing the details, make sure to prioritize the features and be willing to cut when necessary. Not everything is going to make it into the game, and it could be a future feature or DLC. By prioritizing features, we also reduce bottlenecks within this process. Commonly, the most important feature will take the longest to create, and everything else may need to wait. Within this course, you may consider me your instructor to be an executive producer who has set an overall deadline as the assignments. It is your role as the project manager or producer to plan the details and create your own milestones. Now that we have some plans in place, we now need to pay people and consider budgets. The budget is a spending plan. This is always an estimate of the total cost of the project, and we always aim to stay under budget. While it is a nice ambition, it is relatively much more difficult and requires detailed planning. When creating a budget, determining the monthly cost is a great place to start. This comes from the schedule that was created previously. Some common expenses include employee salary, how much each team member will be compensated. External developer and vendor costs are calculated when the other parties need to be involved, either to create assets or systems that are outside of the core development team. Equipment purchases and rental costs can add up, and there's a lot of different types of equipment that we need to create games code, but also the assets. Software costs also plays a role in this as well, as we need to purchase licenses for game engines and other asset creating code. Supplies costs is everything else, such as paper, markers, cards, dice, stationery, and other supplies. Having meetings, we need to consider the travel and meal expenses. Finally, we need to consider the shipment cost of the game itself. The short answer to how much will it cost is, it costs a lot. Let's now put everything together by using some past examples. We will first look at the game design document for Table Tennis for Two. As we can see, the game design is being represented by a wiki, which allows for collaborative editing among the various team members. We can also see the different sections, which include the game design, the technical design, the art list, and the schedule. We can see our overview, and this provides the abstract for our game. We can see how the interactions and rules, and notice the various images provided to explain the game concept. Moving to the technical design document, we can start seeing the scene design diagram along with the details for each scene. Looking a little deeper, we can see the game object and component diagrams, and these are further detailed in the game object list and component list. We can see how the components are expressed by using flowcharts to better understand the logic. Moving forward, we can now see the art list featuring all the visual and audio assets. We can also notice the specific details about each file and its format. Finally, we have our 8-week schedule featuring all the details in the game design, technical design, and art list. This is a similar kind of schedule I suggest that you adopt for your own final project. We see how much of our initial designs have not changed much. More details have been provided in relation to the software being used, but mostly the concept has remained the same. We also noticed that we did not include a specific programming task list, as it's been represented here in the schedule. Now we can see the Game Design Wiki for Galaxy Interlopers. This is a very similar structure as our other Game Design Wiki, so we'll only go over the highlights. We can see our overview here, and this provides the abstract for our game. We can now see our interactions and rules and notice the various images explaining the game concept. Moving to the technical design document, we can start seeing the scene diagram which details each one of the scenes. Looking a little deeper, we can see the game object and component diagrams, and these are further detailed in the game object list and component list. We can see how the components can be expressed by using flowcharts to better understand the logic. Moving forward, we can see in the art list that features all the visual and audio assets, and we can notice the specific details about each one. And finally, we have our 8-week schedule that features all the details in the game design, technical design, and art list. We can see how this process is similar when the details of the games can be very different. Going back slightly, we also start to see some differences between our initial design in this wiki. There are details involving rigid bodies that were not mentioned in the initial design. We remember that these are collaborative documents and each member plays a role in its overall design. This change may have come from the programmer after the team had settled on which game engine to use. Knowing that they are specifically going to use the Unity game engine, the software engineer who knows this engine updated the details to better suit this. The overall concept still remains the same, but the details may be specific to the engine. We finally see the Game Design Wiki homepage for the Hopping Handy Frog. This is again a very similar structure as the other Game Design Wikis, so once again, we're only going to focus on the highlights. We can see our overview, and it provides our abstract for our game. We can see how the interactions and rules and notice the various images providing the game concept. We can then see in the technical design document the scene diagram along with the details. Looking a little further, we can see the game object and component diagrams, and once again, they are detailed in the game object list and component list. We can once again see how components can be expressed using flowcharts to better understand the game's logic. We see in the art list the visual and audio assets, and we can also start noticing the details about each one and its formats. And once again, we have our 8-week schedule. We can see how this process again is very similar, even if the details can change. We can see how much the initial designs have changed from where we left off. As mentioned, we considered that we have settled on which game engine and other tools we are using, so now we can address changing the game specifically. We noticed there are flowcharts demonstrating the core functionality of the necessary components. We also noticed that there is another structured diagram within this section as well. While the game object and component diagrams are used to detail the core game features, there may be some other class structures that provide other functionality that exist outside of this. In these cases, it's worth providing an additional structure or behavior diagrams. For us, we're using an additional UML class diagram to explain more details about this structure. We see that the game data is referencing a level manager by association, meaning that the level manager has one instance of this game data class. We also see the level manager is a component by using the block arrow, but the game data is not. We also notice that the properties and the methods for game data are underlined. From previous software engineering courses, we know that this means they are static properties and static methods. Static in this case means it resides in a single, shared piece of memory that allows for fast and convenient ways to access and modify data and call methods without needing to create a dynamic object. While this is the technical definition, for our purpose, it allows us to create data and functionality that is persistent, meaning it continues to exist across many different parts of our game. The information and methods exist across all levels, all scenes, without worrying about the game engine unintentionally destroying the data when moving from scene to scene or loading and unloading game objects and components. We may consider this to be outside the game engine, but still within inside of our game system. We have spent the past lectures examining the fundamentals of game design through the concept and pre-production phases. By this point, we understand what a game is, what a game contains, who creates a game, and how to create the game concept. We have learned that this is an iterative process that results in a game design document that commonly features an overall game design concept, a technical design document, and an art list. We have learned how to communicate these ideas to our team via a mutable document like a wiki. With our plans in place, we now move to the next level, game development, and focus on production. This is where we must learn how to use the common tools used to create games by exploring engines and assets. In these lectures, we have discussed the fundamentals of games and the process to create them. We have learned how to put our plans together to communicate with our team, and we are ready to start putting it all together. Until then, make sure to double check those plans, and I will speak at you next time. Now it's time for a bonus round. What is the task list? The programming task list is a detailed list of necessary programming assignments needed to create a game. What are some of the common sections in the art list? Visual assets, audio assets, story assets. What is a schedule milestone? Milestones mark a significant point in time for the development process and result in deliverables. What is a good way to derive a budget? Calculating monthly costs from the schedule that includes common expenses like employee salary, equipment expenses, and shipment costs.